Over here we have a very familiar model of the atom. This is the Bohr model. And what you can see here, important features, we have a positive nucleus. The Bohr model is kind of the Hollywood model because it's really easy to draw, where it has different rings, and the electrons would move in circles around the rings. Now, those electrons can jump back and forth, up and down between those models, but Bohr actually got this right, where we get each electron can be in different shells, and we call them 1, 2, 3, 4, 5, 6, 7. It can have 7 shells. They're further apart from the nucleus, and this is actually a pretty good model. It works really well for hydrogen, but it's not complete. What we get from the Bohr model, which is sometimes called the planetary model, is the quantum mechanical model. We know this is more accurate because we don't just have shells, 1, 2, 3, 4, 5, 6, and 7. We have subshells, which are different regions within the shells where the electrons can be. So not only can an electron be in shell 3, there are different parts of this shell that it can be in. And they're not rings anymore. They're going to actually take on different shapes. There are 4 different families of shapes. We call them S, P, D, and F. We'll look at those in a little bit. And then within those subshells, now we can actually get different orbitals. Okay, so rather than all the electrons existing and orbiting on one ring, we get 2 electrons at a time in different orbitals. They still come in pairs. There was a little bit we knew over there, or read into it over there. But the orbitals depend on how many subshells you have. The S's, there is 1 S orbital in that subshell. The P's, there are 3 different orbitals. The D's have 5 different orbitals. And the F's could have 7 different orbitals. Right? So this is what we need to map out. This is actually a big problem now because the Bohr model is really easy to draw. The quantum mechanical model is not. We can't draw the third shell with 4 different regions of space and 16 different orbitals. What in the world would that look like over here? Well, here's what it looks like. You've got a nucleus, and then you get your first shell has an s orbital in it. Okay, we'll learn about how this is constructed later, but just kind of let's look at the drawing. And it's not actually a ring. It's going to be a 3-dimensional ball that's hollow. And the electrons can be on the outside, the surface area of that ball. So there's the first one. The second shell, we get another ball shape. It's an S shape. Again, it's a hollow ball. It's got this one in the middle of it with kind of empty space between them. But the second shell, I can now get a shape that it's called a P shape, and it's this dumbbell-looking thing. There's 3 of those. I've got 3 of those in there in the second shell. When I move to the third shell, I get another hollow sphere with space in between it, so the electrons can't be in that space between them. And then the third shell has a couple of P orbitals as well. And they take up, notice how it's the distance from the nucleus that the third shell, that third region of space, they just kind of layer on top of each other still, but it's shape upon hollow shape. So my third shell, I have all of those, but then my third shell, I can actually add these D's. And if you caught what I'm doing, the first shell only has S's, the second one S's and P's, the third one S, P's, and D's. The fourth one will be the first one that has all 4. Doesn't mean they fill up in that order, but that's kind of where we're at. The D's in that third shell, they kind of have these flower-looking shapes. One of them has like a donut in the middle. There's one that kind of goes back and forth along the axis, and there's one more going up and down like that. And I don't have to draw those accurately because you can't see it in there anyway. The fourth one, you see the problem all of a sudden? Because the fourth one now has the S, the P's, it's got 5 D's and then 7 F's. And then there's a 5th layer and a 6th layer and a 7th layer that has all of these things potentially in there, and the electrons can be in this cloud. Now, 2 things are really obvious here. We can't predict the motion of the electrons anymore. Over here, it was really nice. They were circles. they don't move in a predictable way over here. They don't even move in a predictable location. We give them a region of space and we say it is somewhere in, if we just took one of those p orbitals and said it's somewhere in there, we don't know where that electron is moving. We can't draw it anymore. So what we're going to do is we need another way to map out the electrons because we still need to talk about where they are. So this is kind of the backstory from the Bohr model to the Schrodinger model to why we do electron configurations and orbital diagrams and how we read those. Because really what happens is when you're doing an electron configuration, you are actually doing an updated version of this Bohr model, but we can't do it visually, so we've created something else to map out the electrons and tell us about the structure of the atom, because this is insane.